This chapter is all about rational expressions, and the first section is about equivalent rational expressions. Now, what is a rational expression? Well, the key to understanding a rational expression is to look at the first 5 letters of the word rational. So just like a rational number is a ratio of 2 integers, a rational expression is a ratio of 2 polynomial expressions. So essentially it's a fraction where the numerator is a polynomial and the denominator is a polynomial. So again, just a quick recap. What's a polynomial and what is not a polynomial? A polynomial is simply a sum of monomial expressions where each monomial is a product of a coefficient and some variables. Each variable has to have a whole number exponent. So no negative exponents, no fraction exponents. The exponents are going to be 1, 2, 3, 4, etc. And the coefficients can be anything, but most of the coefficients we're going to see are going to be integers. Now, the first thing to understand is that just like a fraction, you cannot divide by 0. You can't have 0 as a denominator. Now that's pretty easy to watch out for when you're dealing with regular fractions where the numerator is a number and the denominator is a number. But when the denominator is an algebraic expression, a polynomial, you actually have to be a little bit more careful and you have to state which values are non-permissible values. So how do you know what is a non-permissible value? Well, let's take a look at a very simple example, something like x plus 1 over x. What you have to do is ask yourself, when is the denominator 0? We have to ensure that the denominator can't be 0. And you can just simply write whatever the denominator is not equal to 0, and then simplify that expression if need be. So in this case, you just simply write x is not allowed to equal 0. Let's look at something increasingly more complicated, bit by bit. What if we have something like x plus 2 over x plus 1? Now, keep clear, it's perfectly acceptable for the numerator of a fraction to be 0. 0 divided by something is just 0. But the denominator is what we have to worry about. And so just start by writing the denominator is not allowed to equal 0, and then simplify that expression if you can. In this case, it's very easy to subtract 1 from both sides. And so you would write x is not allowed to equal negative 1. So again, let's work our way up to more and more complicated things. What if we have x plus 4 over x squared plus x minus 6? Well, it's not immediately obvious what values of x are not permissible, and so really the first thing you want to do, and this is actually good advice for dealing with any rational expression, first thing you want to do is factor everything. So the numerator is fine the way it is, not much we can do with it, but the denominator factors as 2 binomial expressions, x plus 3 and x minus 2. Now, neither of those factors on the bottom can be 0, so if you're not sure what to write, you can just simply write x plus 3 not allowed to equal 0. Simplify that by subtracting 3 from both sides, and you get x is not allowed to equal negative 3. Similarly, x minus 2 is not allowed to equal 0, and if you add 2 to both sides, you get x is not allowed to equal 2. So ultimately, you'll get pretty good at this, and you won't need to write out the initial step there. You'll just simply write the restrictions, which is x is not allowed to equal negative 3 or 2. Now, as I just said, you're going to have to factor, and if I have 3 words of advice for this whole chapter, it is factor, factor, factor. You're going to have to factor everything, and it's one of the reasons why factoring is emphasized so much last year and emphasized a little earlier in the year when we were looking at solving quadratic equations. Even though you can always solve a quadratic equation using completing the square or using the quadratic formula, we learned about factoring and we reviewed factoring because it really just is incredibly useful. And for this chapter, there's really no escaping it. You're going to have to factor. And for some problems, you're going to have to factor 2 or 3 expressions before you can get to a simplified expression. So there's going to be a lot of factoring. Now, let's take a look at simplifying these expressions, because simplifying these expressions is really just like simplifying fractions. And so you have to remember how to simplify a fraction. And to simplify a fraction, you're looking for common factors in the numerator and the denominator. So if we just have monomials, it's a very easy task to find common factors. So you can start with the coefficients if you like, 5 and 15. 5 and 15 have a common factor of 5. And then the x squared and the x have a common factor of x. And so you can rewrite the numerator, if you like, as 5x times x. And you can rewrite the denominator as 5x times 3. So it's only these common factors that you can eliminate. And when you eliminate them, you're left with x over 3. So we started with 5x squared over 15x, and we're claiming that that's equal to x over 3, but we have to be a little bit careful here. When you make this sort of claim, where you have an expression with a variable, and you're claiming it's equal to another expression with a variable, what you're really saying implicitly is that this is true for all values of x. But in fact, it's not. We can try a couple of values and find out what happens. So if we let x equal to 1, for instance, the left-hand side would be 5 times 1 squared over 15 times 1. And this is just 5 over 15, which simplifies to 1/3. And obviously the right-hand side, if we let x equal to 1, we get 1 over 3, and that's true. That's great. But is this going to hold for every value of x? Well, it is, with one exception. What if we let x equal to 0? If we let x equal to 0, the left-hand side becomes 5 times 0 squared over 15 times 0, which is 0 over 0. And that's undefined. It's not a number. Whereas the right-hand side becomes 0 over 3, which is a perfectly well-defined number. It's just 0. So these things are not equal to one another. And this is really the reason for writing restrictions or non-permissible values. We sometimes refer to non-permissible values as restrictions. And so I would suggest the first thing you do before you start simplifying, or later on adding, subtracting, etc., is to write the restrictions. So in this case, when you're looking at the denominator 15x, that can't be equal to 0, and the only way that's going to equal 0 is if x is 0. So your restriction that you should write first is x is not allowed to equal 0. And then the way you can interpret this is 5x squared over 15x is equal to x over 3 for all values of x, with that one exception. Now, let's again start getting a little more complicated and look at a rational expression with some trinomials. What if we have x squared plus 5x plus 6 over x squared minus x minus 12? Again, factor, factor, factor. It's going to be pretty tough to tell what the restrictions are until you have factored the denominator, but we want to factor the numerator at the same time. So let's write the numerator as x plus 2 over x plus 3, and the denominator as x minus 4 over x plus 3. So now we can see that the denominator has two binomial factors, and we can write the restrictions. So what are the restrictions? Let's write them over here on the right. X minus 4 would equal 0 if x were equal to 4, so that's one of the restrictions. And x plus 3 leads to a restriction of negative 3, because if x is negative 3, then that factor would equal 0. So you get two values of x that will give you a denominator of 0, and both of those you have to identify. Now you can also see that once you've factored it, it's pretty easy to identify common factors. And the common factor in this case is the binomial x plus 3. So you can eliminate that common factor, x plus 3, and the simplified expression is simply x plus 2 over x minus 4. Now, You can do some quick checks to see if you're on the right track and pick some values of x and see if the left-hand side really does equal to the right-hand side. So for instance, if you let x equal to 0, you just simply get 0 plus 0 plus 6, 0 minus 12 on the left-hand side. The right-hand side becomes 0 plus 2 and 0 minus 4. So 6 over negative 12 is negative 1/2. And that's equal to 2 over negative 4. So this does not guarantee that you've done it right. However, if the left-hand side did not equal the right-hand side, and you had not chosen to plug in a restriction, then that definitely would indicate that you'd done something wrong. So let's try this again. We'll pick a different value. 0 is not a great value because obviously it eliminates every term involving x. And so if you had x squared plus 6x or x squared plus 7x, doesn't really change when x equals 0. If you let x equal to 1, at least you'll be taking into account the coefficients. So then you have 1 plus 5 plus 6 over 1 minus 1 minus 12. And that's equal to 12 over negative 12, which is negative 1. The right-hand side becomes 1 plus 2, which is 3 over 1 minus 4, which is negative 3. And that's also equal to negative 1. Now, let's just try plugging in one of the restrictions to see what happens. If we let x equal to negative 3, the left-hand side becomes 9 minus 15 plus 6 over 9 plus 3 minus 12. And that's equal to 0 over 0. What's the right-hand side? Negative 3 plus 2 over negative 3 minus 4. Well, negative 3 plus 2 is negative 1. Negative 3 minus 4 is negative 7. That's 1/7. So 0 over 0, which is not defined at all, is clearly not equal to 1 over 7. And this is not proof that we've done it wrong, because we identified negative 3 as a restriction. All right, but this is a clear indication of what happens when you plug in a restriction and why it's important to write the restrictions. All right, we are claiming that this complicated expression to a trinomial over a trinomial is equal to that more simple expression for all values of x. But it clearly is not true when x is equal to negative 3, and equally not true when x is equal to 4. All right, let's try one more. 2x squared minus 11x plus 5 over 4x squared minus 1. If need be, go off on a side or a separate sheet and factor these. The numerator factors as 2x minus 1 times x minus 5. The denominator factors as 2x minus 1 and 2x plus 1. It's a difference of squares. So again, as soon as we have the denominator factored, you want to factor the whole thing, but as soon as the denominator is factored, you can write restrictions. In this case, 2x plus 1, when is that going to equal 0? It's going to equal 0 when x is equal to 1/2. And 2x plus 1 is going to equal 0 when x is equal to negative 1/2. So those are our restrictions. If you can't come up with those in your head, you can do it the long way and just write 2x minus 1 not equal to 0. Simplify that expression and do the same for 2x plus 1. These are obviously common factors here, 2x minus 1 and 2x minus 1, so we can eliminate them and end up with our simplified expression, which is x minus 5 over 2x plus 1.